So today I'd like to introduce a new and exciting product to you, a wireless cable sensor. The aim of this product is to measure power, current, voltage in a cable that is already installed in a field or is already powered. If you want to measure power, I'm talking about voltage, current, real power, apparent power. The typical way to do that is to use a clamp meter like this. So a clamp meter, you can open that here and you clamp it around the cable, and then the principle to measure it is that the flow of current which goes through the cable generates a magnetic field, and that magnetic field is measured by the clamp. A clamp meter has two big disadvantages. First, it's not very accurate because you can only measure the amps, not the voltage in a cable, and not the power factor, and certainly not the real power in kilowatt hours. You have to assume a certain voltage and a power factor to estimate and calculate the real power using these assumed values. Since this is the only non-intrusive way to measure without shutting down the power and cutting into the cable, this is still the most common way to measure. The second disadvantage is that a clamp meter only works on a single wire, not on a cable like that. This is due to the fact that the clamp measures, as I said before, the magnetic field rather than the real amp. In case of a cable like this, there are two magnetic fields generated. One is generated by the wire which goes into that direction, and another one is generated by the wire which goes right in the opposite direction. Unfortunately, both magnetic fields are identical because the same current which flows to the load flows back from the load, but they are opposite in direction. Hence, if you apply a clamp to a cable like that, you meter nothing. The one solution to overcome that is to unstrip part of the cable. Now that can be done typically with a knife that you cut the outer wires, but this is number one, not too professional, and number two, it's also dangerous, particularly if there's power in the cable. I want to show you a very sophisticated tool to unstrip a cable without cutting into the wire. The tool to use that looks like this. It's again almost a clamp which is clamped around the cable. But inside the clamp, if we open it here, we see there's a little knife. And that knife, number one, can be turned in direction, either that way or that way, and it can be adjusted in the height or in the depth. So, if we now turn this knife into the radial position like this, and we clamp around the cable, then the knife slits into that outer coating. Then we twist it one time would be enough, and now we turn it into the different position. Now the knife is like this, and we just move it a bit, and now we turn it again, like this, and we twist it again. And now we remove it. So now what happens is that, as we see here, a little slitting in the outer coating of the cable is there, and now we just need to do this. And on the other side. And then we remove the coating. That's exactly what would be needed for a clamp meter like that. Now we can clamp an individual wire. The big advantage of this is not only that it's fast, but also that it does not cut into the inner wires. If we look in here, there's no cutting, so the inner wires and the inner isolation of these wires are intact. The only thing you lose by doing that is the protection against stretching that cable. But from the electrical isolation point of view, this is totally isolated on both sides, simply because we do not cut totally into that coating, but we only slit it on the surface and then open the rest. So this is the first step to make a sophisticated measurement of the power which goes through this cable. Now we can already use a clamp like that, but as you see, that clamp is just hanging wildly on the cable, so that's not a good idea either. For this, we have developed another tool. It looks like this. Essentially, it's again a clamp meter. So the clamp is here. It has the same function like this clamp, it's just a bit smaller. Now, in order to measure, we need to put one wire through the cable and the other wires outside that clamp. Let's see how that would work. We see here our D-strip part, and to apply that, one cable goes inside and the others are outside. Now, we could already put the cable here into these holdings and close it. And then we would have pretty much the same function like in the old-fashioned clamp meter. However, the thing needs to be powered, and we want measure more than just the amp. The trick here is this little tool. It has some electronics below, and it has, as you see, two little teeth. Now what we do is we take two of these cables and we let them run through these teeth. Still, the inner coating is intact. What we now do is we close this, what sometimes is called a mouse trap, and we put that in here. Now we see that there's only one way that can go through, and then we can close the whole thing. Click. Now we see that this is the neutral wire, which is outside, and the two wires go in here. At the moment we close that here, these little teeth penetrate the inner isolation of these two cables and get in contact with the voltage and the power inside the cable. There are two reasons to do that. Number one reason is it powers the electronic which is needed for the measurement, so we don't need any batteries. The second reason is that we can measure the voltage. If we can measure the voltage and we do not longer need to estimate or calculate voltage and power factor, like in a clamp meter, we can measure the apparent and real power in that device very accurately. Only with this it's possible. Now there is one trade-off. We need to penetrate these wires to get in contact with the copper part. However, this is only done if we close this thing. As long as this is still open, the wires are not penetrated. At the moment we close it, there will be pressure on this, and then the little teeth goes into that inner wire, but at the same time that portion here will shield that part from any touching from the user. So, I now position that in here and close the trap. And what is then needed is only the covering here. And you see here and here there is a certain mechanism here which makes sure that the outer coating is held so that there is again protection against stretching of this cable. So if we close that and close it together, then we have the final configuration, and this is the sensor. At the moment we close this, we know, and power goes into the device, it gets powered, the electronics gets powered up, it's measuring voltage, amp, power factor, etc. pp. And it's transferring its measurement signals outside wirelessly.